Hello, everybody. Welcome back to another round of Geek Talk. And this time we have Dejan Sarka with us, and we're going to talk about data science algorithms. Just to let you know, every Thursday we are doing series of Geek Talks on various technologies in data analytics and AI world. And this, I think, is the fourth Thursday. So we already have about kind of 10 to 12 Geek Talks on variety of topics already delivered, and very soon we will share the recordings also. We'll put them up on, and some of them are already on YouTube, but we are going to put more of them on our website, dataplatformgeeks.com, sqlservergeeks.com, and sqlmaestros.com. And as usual, I'm donning the Data Platform Virtual Summit background that you can see. So visit dataplatformvirtualsummit.com if you have already not gone there. There's a lot of goodness there. It's more than a conference. It's really a mega learning event. More than 200 breakout sessions are going to be delivered. We have scheduled more than 30 training classes. And the best of all for the community is we're giving out all the recordings to delegates for for 12 months on-demand access. I mean, so that our audiences, the community becomes the true winner. And of course, the entire event is priced quite community friendly. So that's where we are with the Data Platform virtualsummit.com. So take a moment to visit that. Now, those of you who are on dataplatformgeeks.com/live, you can see the Zoom link is available. So we have room. If you want to jump into Zoom, you can do so because you get better interactivity, Q&A panel, etc. Those who are watching live on YouTube, you can use the YouTube chat window for question and answers. We'll start off with our discussions with Dejan, and then keep your questions coming in. And our colleagues, Satya and Aarti, who are supporting us, will take your questions from YouTube chat window and put them in the Q&A panel of Zoom. But if you want to join in Zoom, you're most welcome to do that also. Well, with this, let's get started. My name is Amit Bansal, and I'm going to be your host for next 45 minutes. And let's see if Dejan is there. Dejan, how are you doing?
Hi, Amit. Nice to see you. I'm glad and very happy that you invited me. I see that this is really a great event, great community. So very nice morning for me to talk to you.
Absolutely, Dejan. It's a true pleasure to have you. So friends, let me introduce Dejan in my own friendly way as much as I know him. So of course, I've been knowing him for many years. He's a fellow MVP and of course, a great voice, true expert in data, in T-SQL, SQL Server, data science, whatnot. I'm like, he's flying around with a lot of technologies, and I see him in so many conferences, events, and delivering top-notch sessions. So it is a true pleasure to have Dejan today for the Geek Talk. He's also a speaker at Data Platform Virtual Summit and is also doing an 8-hour class as part of Data Platform Virtual Summit. We'll talk about that later, but Dejan, over to you. So first, you can introduce yourself to our audiences today.
Okay. So thank you for this nice introduction. Let's go, let's say a little bit more formal. First of all, I'm getting quite old. I'm pretty long in this area. For 35 years, I'm dealing with IT business, and I started in '85, and I started first was 1 year teaching mathematics on high school, and then I went for 5 years to university dealing with statistics and teaching statistics. And then in '90s I went to business area, and in '92 I met SQL Server for the first time, so it is also quite a long time. I started with SQL Server with version 4.2, if I remember, or it was 4.21, if I remember correctly. Anyway, and then I continued to work with SQL Server, and with SQL Server 7.0, 98, SQL Server also started with business intelligence, OLAP server, which is later renamed to analysis services. And then in 2005, SQL Server for the first time introduced data mining. So I went back to my original area, statistics, data mining, and so on. And now in 2016, R support was introduced, 2017, Python. So I'm back in this data science area, although, as I said, I still worked some parts of, I didn't focus only on line of business applications. I still worked with analytics, though not so intensively all of these years. And I co-authored 18 books so far. So I guess this is a huge number. Some of them alone, some of them with other speakers on this conference. For example, I did a lot of books together with Itzik Bengan. We are very, very good friends, and also some other guys. And that's more or less it.
Great, great. That's actually a lot of experience, not just more or less. So when you started, I was doing my schooling that time, and I think many of us would be in school at that time. So Dejan, thanks. A true pleasure to have you on board. So let's get started. Data science algorithms. You know, when I hear about data science algorithms, what really do they mean? Are we talking about these algorithms that have been there for years, like time series, naive Bayes, clustering? Are we really talking about these algorithms that we apply to the data, and it gives us a lot of intelligent information based on which we can take decisions? So let's start with that general thing about what are these data science algorithms?
Okay. So, you know that data science is now a very, very fashionable thing. Everybody is talking about this. Many people are moving to this area. And still there is kind of perception that you just need to get some data, whatever shape it is, and then you feed some black box data science engine. And on the other side, you will get out great results, great information, and suddenly your business will go much better. Unfortunately, from my experience, it doesn't work like this. And I've been through many waves when these things were fashionable. So, you know, first I started with statistics, and then in 90s it was fashionable to talk about data mining, and then 10 years later it was another way. So it was very fashionable to talk about machine learning, and now again renamed and another wave data science. But every wave so far finished somehow badly, because you know people started the same way like they start this time. So everything will be easy. We just throw data in some engine and we get great results. And companies were spending resources, were spending money, and the results were not exactly what they expected. So then, you know, after a couple of disappointments, the wave, or the big wave of this advanced analytics went down. And it happened, as I said, many times in the past. When you are long enough in this business, you see that everything goes in cycles. So now we are on the top of another cycle when this advanced analytics is called data science. However, still all of the same problems are there. And the main thing is that without knowledge, you cannot really expect that you will get good results. I mean, if I am a little bit sarcastic, and I can be sarcastic since my last name is Sarka. Okay? So anyway, if you give a calculator to a monkey, you don't get a mathematician, you just get a monkey with a calculator. I'm sorry, you know, also artificial intelligence can't help you without natural intelligence. So this this seminar is about explaining how these algorithms work. I mean, what is the mathematics behind? And by understanding these internals, you can also understand what are the strengths and what are the weaknesses of each algorithm, when to apply each algorithm, and what kind of problems can you solve with some algorithms. And as I said, especially to also understand the weaknesses, so you can also, with this knowledge, you can also properly interpret the results. And when you properly interpret the results, you can take a proper action.
Right. So Dejan, you know, you brought up a very valid point that years back when this was very fashionable, I mean, it is still fashionable today, but then years back when it all started, And I also remember when you use the word data mining, there was data mining in Microsoft Excel. I remember there was a data mining add-in, and we used to select data and then apply some algorithm. It will give us some result sets. And you're right, it did not give the results that companies or enterprises really wanted. So what has changed from that point to now? I mean, after 10 years or 15 years, how are things better today? And why do you think, or why are you confident that we will get results today from these algorithms?
Well, as I said, some problems are still the same. Basically, as I said, without knowledge, it's still, even with better tools, it's still very dangerous to use these data science tools without knowledge. However, also technology has matured a bit, but mostly I think because of big amount of people that are going into this area. Also, the awareness has spread around, awareness that you need to understand what you are doing. So I hope that this time it will be better than in last waves, because more and more people understand that it doesn't work like this. It doesn't work like, just give me some data and some engine and I will be a genius and resolve problems. And I think the awareness is bigger than any time in the past.
Right, right. Now, and Dejan, with my basic understanding about these algorithms and overall data science is at the core, we have data. And I remember when I was playing around with these algorithms, if a company, if an entity does not have good data, they do not have enough good attributes and they do not have enough amount of data, then of course algorithms are going to produce incorrect results or maybe not full results, and that may really lead to disaster if people depend on that kind of result. So I think that foundation has still not changed. I mean, data is at the core of it. You need clean data, you need data with good attributes, and you need enough amount of data for the algorithm to create, so-called models and things like that. I mean, is my understanding right there?
Yes, yes, it's mostly right. First of all, it is still the same as it was in the past when you start any kind of BI or data science project. You spend like 80% of time with data cleansing, with data
Right.
preparation, and with basically you have, as you said, you have some source data which might be unclean, which might be a lot of missing data, and definitely you don't have in these transactional systems many variables which would be immediately useful for advanced analytics.
Absolutely.
Uh, However, I would just like to correct you in two small issues.
Right.
First of all, for these data science algorithms, many times you do not really need a lot of data. This is
Okay.
kind of perception, big data.
Hmm.
However, these algorithms come from statistics mostly and are tailored to work on samples. Samples means you need a couple of 10,000 of cases. You don't need like billions of cases. Some
Right.
algorithms also work well on billions of rows, but some are really tailored to work better on these samples. And for example, clustering is a typical algorithm that if you feed it with too much data, you will get what is called local maximums. You will get clusters that are not really important for the whole
Mhm.
data set.
Right.
So you again, but a nice remark, because again, you have to know what you are doing to fit proper algorithms with proper amount of data. And the second thing is when we talk about data, you mentioned we don't have um, correct variables prepared. That is also true, but it's not so hopeless. Many times you can create derived variables which are extremely useful, even if there looks at the first glimpse that in the source data there is practically nothing to analyze. Now, let me give you a concrete example. So I worked in the past many times on fraud detection projects, and I remember a fraud detection project which I worked for one bank in Italy for online banking. So initially we didn't have anything practically nothing about users. What you have is IP address where the user logged in, and the username and the time when the user logged in, and also time when the user logged out. And how can you analyze this? But with the business knowledge, we created some extremely useful derived variables out of these three source variables. So we created derived variables which told us how many times the same user connected from different IPs, even in different cities, in a specific time frame. And how many times different users connected from the same IP in a specific time frame. And these variables then turned out to be extremely useful for the analysis. So we really managed to catch 70% of frauds immediately before the customer even realized that something is wrong with their accounts. So it's not really hopeless situation. But sometimes when you look at the source data, you just start scratching your head and say, okay, what can I do here?
No, absolutely. So, audiences, friends, couple of important takeaways. I mean, if you're taking notes, one is clean data is very critical. And as Dejan said, you're spending most of your time cleaning the data because that's going to be the source. And the second is you do not need billions of records, right? You just need a good amount of samples. That's enough for the algorithm to run. And in contrast, if you have a lot of data, maybe the algorithm, and of course it depends from algorithm to algorithm, but if you really have like billions of records you're feeding into the algorithm, you may still get incorrect results. So these are some important takeaways, right, Dejan?
Exactly. And I just see a question. Can I read it? So
yeah, Dejan, we are coming to Q&A just in 5 minutes. So let that be
okay.
there.
Sorry. I just wanted
No
to,
problem,
sorry.
no
Yes,
problem.
yes, because it
No
was,
offense to the guest who has put up the question. So thanks for reminding me that, friends, keep your questions coming in the Q&A panel. In just about next 10 minutes, we'll jump into the Q&A and start asking questions. So as I mentioned earlier, if you are on our live page, which is dataplatformgeeks.com/live, or if you're in YouTube, you want to come over to Zoom, do that. If you are comfortable there using the chat window, put your question there. We'll put that into Zoom. Our colleague Satya and Arti will help there. Great. Dejan, give us an example of any real life, real world, anything recent that you might have done with some data science algorithm in some business or industry, anything that comes to your mind.
okay. As I already mentioned, fraud detection, I actually worked on quite a few really huge fraud detection projects with some banks and with some credit card issuers. So altogether, I had like at least 8 really huge fraud detection
Fraud
projects.
detection.
Yes, and this is quite complex thing
Com-
because this is ongoing. It is kind of never-ending project. It's much more complex than having one-time marketing action. And then in the past, I also worked a lot on this public opinion researches. So I did a lot of analysis. I mean, this will sound funny, but it's true. I worked on over 700 projects about public opinion in my country, in European Union, and in all of the world. So why I went in 90s, I was practically having monopoly around in Europe on this statistical analysis of these researches. And I went out because I got too bored. So I went seriously for a few years. I didn't even touch statistics. I really went only to transactional systems focused on SQL Server. So yes, over 700, you can imagine that at some point I was really so bored. I really didn't care what people think anymore, who cares anymore?
Right. Dejan, which are the popular tools? I mean, okay, algorithms are open source, they're widely available. So, but which are your favorite tools to kind of, implement them? I know we have machine learning in Azure, but then apart from that, what are the popular tools in the market?
Okay, for data science, for statistics, for many years, my first tool of choice is R.
R.
R, Yes, of course, in the 80s and 90s, I also worked a lot with us SPSS. And I did also, it still can be useful. Analysis services, data mining. It's a simple tool, simple to use, but not everybody that needs some advanced analysis wants to go the full data science part and learn a new language. But still, my preferred tool is R, although lately Python is also becoming popular. So I already
Right.
had some projects with Python as well when the customer wanted to go more the Python way. But I still prefer R.
Perfect. Perfect. I mean, of course, R is very popular and Python is very upcoming. In fact, I was just watching on LinkedIn, how programming languages have become popular over the year. And suddenly, Python comes and is kind of taking some top slots as a very popular programming language. Great. So let's do one thing, Dejan. We have a lot more to talk, but let's go and see. There are a few questions coming in. So we'll take the first one. Atharv has a question. What is the core difference between supervised, unsupervised, and reinforcement learning algorithms?
Okay. It is actually, I think, the second question, but let's start with this one and then let's answer the first one. So, supervised are algorithms where you have a target variable and you try to explain states of this target variable with input variables. And you will see in the seminar why they are called supervised when you develop the model, when this mathematics behind the target variable is supervising this development. So for example, decision trees, you have target variable, which is, let's say, simple binary, true, false. And you try to explain these decisions with input variables. And when you develop a tree step by step, in every step you use target variable, you measure purity of subclasses, and purity is measured based on target variable. And then you select the step where you improve the purity of target variable, which means forcing one state only, yes only, or no only. And this way, target variable is supervising the development of the model. Unsupervised means that you are simply fishing in the mud. You are trying to see if there is some pattern in your data without any specific target variable in your mind. And typical example of unsupervised algorithm is clustering. So you just use input variables to try to find similarity of cases, like similarity of people, similarity of your customers, or similarity of your employees. Or also, it's very useful also in biology, similarity of habitats and so on. And you don't have the idea what these classes are. So once you got the results, it's the next step is the battle to interpret these results properly. And reinforcement learning is kind of a new thing, which is slowly gaining popularity. So it is more going to, let's say, artificial intelligence part. So this is kind of mixture of supervised and unsupervised. You have a target variable. However, this target variable is not really supervising the development of the algorithm or the development of the model. You are supervising the development of the model by giving the model awards if it goes to right direction and punishments if it goes to the wrong direction. And then at some point when you come to the end, you use the results for predicting, let's say, target variable. And this is kind of like becoming popular because it's also resembling in a way the real life. You go to some direction and then you see there is some stop sign or one-way road, and then you turn around and go to another direction until you find the end. However, at this point, where are we? We still use mostly supervised and unsupervised algorithms. Reinforcements algorithms are in a big thing, a new big thing, developing quickly, but we are still not so sure in which areas they perform better than others. But I guess at some point they will become really, really prevailing algorithms.
Right. Long answer, Atharv, to that question on supervised, unsupervised, and reinforcement learning. So Conrad Braganza has a question. Can we say that if the test data is fully representative of the real world data, including common edge scenarios, then this will be mostly sufficient for model training?
Yes, the simplest answer here is just yes, the shortest, and a little bit longer. Of course, we know for many years, for decades, what is statistical sampling, and the point is that you really need to get the representative sample of data. But first, you have to understand what is your target population. So if your target population are, for example, university students, then you don't need data about retirement people, right? So first that you get target population, and then of course you have to get a representative sample, which means that all subcategories of this target population are properly represented in sample. Now, just one thing more, including common edge scenarios. Edge scenarios, this can be tricky. Maybe for some things you just want to exclude the edges. You want to exclude like the extremes, the outliers, because they might influence on the development of the model simply too much. And again, it really depends what is the target of your analysis. And as I said, just imagine, for example, that at this moment, Bill Gates would join this talk. In average, we are billionaires immediately. So if you want to evaluate, let's say, our income of people we are here joined to this talk, then probably you don't want to have also Bill Gates in this group, because then your evaluation will be wrong. But if you want really to get overall impression, then you probably want also to include the edge cases. So this with edge cases, the short answer is it depends. To repeat, first short answer was yes, but then with slight correction, it depends for the edge cases.
Yes. Thanks, Dejan. We have another question from Michael in the chat window. And the question is, how do you go about selecting the correct algorithm for the job? Do you think that only people with a deep understanding of statistics should be applying data science, or do business users with a good understanding of the data have a chance to get meaningful results? From Michael Berry.
Okay, so
long question. So if you want to read that, Dejan, it's in the chat window.
Yes, I see it. I read the chat window. Okay, first of all, it is you have to understand that not every problem has the same complexity. So I mentioned two examples: fraud detection and marketing campaign. Fraud detection is a very complex problem, and marketing campaign is a very simple problem. And you really don't need to go in depth for all of the statistics and everything to make a good model for a single time marketing campaign. Well, how do I see which problem is complex and which is simple? First, you have to think, is it one-time thing, or is it something that is continuous? And whatever you do only once is immediately simple. I always remind myself on a nice book of Milan Kundera, Czech writer, The Unbearable Lightness of Living. So he was like forbidden writer in times of communism. And in this book, he explains that it is really easy to bear everything that life brings to you because you live only once. And everything that happens only once is a very simple end. I know, yes, in India you believe in reincarnation, but let's leave these things for the moment. This is the point of Kundera's book. And by the way, Czech Republic is probably the most atheistic country in the world, so no wonder that this book appeared there anyway. So this is still the same. You can apply this everywhere, also in data science. If we have a problem that we need to solve it only once, then this is simple. Then you don't need to go full data scientist path and learn everything from the scratch, from basic statistics onwards. That's why I also, if you remember, not a couple of minutes ago, I mentioned that even this good old analysis services, multidimensional data mining might still be useful. It is extremely simple to use. It is very limited, but not everybody needs these huge tools and learn a new programming language and understand all of the mathematics for getting some valuable results. But if you really want to do, as I said, this complex problem like fraud detection, then you probably want to learn a lot. By the way, there is also one more thing that is extremely important to evaluate whether the problem is simple or complex. First thing is, does it happen once or is it continuous? And next thing is, what are the side effects? With marketing campaign, there are practically no negative side effects. For example, you select people that are more likely to be interested in your product. So you simply means by selecting those people, you are sending less spam mails and so on, so everybody is happy. With fraud detection, we have already a huge problem. I said, if you remember, like important input variable was how many times the same user logged from different IPs in a time frame. What is the problem here? We can easily get false positives. We declare something as a fraud and punish probably your best customer, because this is similar behavior that business people have. You know, they travel, they for example, pay hotel, they pay flying tickets, airplane tickets. So they are spending quite a lot of money in different places in a limited time frame. So you have to be very careful with false positives. And then I will tell you about another project I had. I had this project in Serbia. So it was a project where we tried to predict areas that are prone to landslides. And this is a huge thing if you think about false negatives. What does mean false negative in this context? You predict there will be no landslide here. So this is a negative prediction, but it is false. So people build houses there and then a landslide happens. And I mean, come on, you know, the side effects are extremely, extremely bad. So people lose their houses, maybe even some people die. So in this case, I would say don't do this if you don't have really deep understanding about all of the measures and how did you get there. Otherwise, side effects can be extremely, extremely huge and extremely important.
Wow, loads of information and experience from you, friends. As we get into more questions, so we've just put up on the screen for you. This is Data Science Algorithms 8-hour class by Dejan Sarka as part of Data Platform Virtual Summit. And just to reiterate, apart from attending live, so you have 4 hours each day. We split this into 2 days, 4 hours each day, total 8 hours. Apart from attending live, you also get the recordings of the class. And no conference does that. And we're doing this as a good thing for the community. So just log on to Data Platform Virtual Summit, explore the conference, explore all the classes that we have to offer. Right. Dejan, one question I had before we go to more questions in the chat, and do we have in chat window? And yeah, links are there in the chat window, friends, if you just want to copy paste and put them into the sticky notes or wherever and take a note of that. Dejan, you know, I know we talked about cleaning the data. We talked about having the right data and all of that, but what are the uncommon challenges that could happen in a data science project, so to say, something that is not much talked about but you have encountered while trying to get results to the customer?
Okay, you have to be prepared on surprises with the results. So also it's not just important to mathematically correctly interpret the results, but also from real life point of view. Okay, so I will tell you an example where the results were really surprising for my customer. And it is a serious example. I will not tell the exact customer, but I will tell the country and you will understand the problems. So I'm talking about North Macedonia, and I
Which
worked there
which country?
for
Sorry, Dejan?
Macedonia, North Macedonia.
Okay,
North
Macedonia. Okay.
Macedonia, okay. So in Macedonia, the prevailing nation are Macedonians, but then you have a huge Albanian minority and smaller Serbian minority. And the customer was a bank and was trying to analyze also using the nationality which kind of people are bad with returning loans, and you should avoid them to give loans. And this was like more in the Macedonian nation prevailing area. So at that point in time, it was like 15 years ago, at that point in time, there were some tensions between especially Macedonians and Albanians. Fortunately, now everything is nice there. Anyway, the big surprise was that the best nation to give loans were Albanians. They wanted to show exactly the opposite. Unfortunately, they were disappointed. So at least I hope this project helped in better understanding between nations. But I remember that they were really surprised. No, it can't be true. They want me to correct the results. I said, sorry, but this is what I get. Sorry, this is what your data is showing. This
So
was
this
a
is
nice example.
very, very interesting scenario, because this reminds me that sometimes when customers are signing up for such projects, they pre-decide the kind of results that they want to see. And and of course, if the results are otherwise, they will definitely be surprised. Great example there. So friends, any more questions we have there? Um, and yeah, friends, the Geek Talk for not next Thursday, but Thursday after that, because next Thursday we have a full day, 24 hours live event on artificial intelligence and advanced analytics. Virtual symposium is what we call it. It's a 24-hour round the clock event. You can join in from anywhere, anytime. Just go to dataplatformgeeks.com and you will get the necessary links. Go to the event section. So the next Geek Talk for October 15th is already up. You can sign up for it. That is on dataplatformgeeks.com/live. All links are there in the chat window. And that Geek Talk is about Azure Synapse Analytics. And again, just like Dejan, one of our experts, Warner Shavs, another MVP and MCM, he will join us and we're going to talk about that. So we have another question or two coming up. Great. Michael Berry has another question, but as you corrected me, okay, now that's the first question. Okay. So the question, Dejan, is how do you go about gaining trust in your results when you come up with something surprising like that?
Yeah, this is a hard question because when people don't believe you, then you really first try to go through your process again and again to see if you made any mistake. And also you try with different algorithms, with different ways of showing the coming to these results. And when you go through different ways and you come to the same result, then you slowly, step by step, build trust. But as I said, if people sometimes really expect something different, then you are in a problem. And I also worked in this area. So when I worked in the late 80s in university, remember, this was the time when in former Yugoslavia, there was still socialism. So we got some orders for some researches from the government, and we got also the money, and we also got desired results. So then what do you do? Because if you don't show the desired results, you are not even published, it's not good for your career and so on. And I can tell you what we did at that time. Sometimes, and this is what actually I did. So instead of spending money for really going out and asking people and maybe getting wrong results, we made up the data. So I created sample data that showed the correct result, and we simply spend the money on ourselves instead of spending on the research. So yes, I know it sounds very bad, but this was communistic times. And let me just jump away to the next room for a second, because I have an important question back for Michael Berry. Just give me the second, you hear me? And I just wanted to ask whether this Michael Berry is the same Michael Berry that wrote a couple of very good books about data mining together with Gordon Linoff. And Michael, is that you? Are you the author of these books? Oh, it's not. Sorry, I was really amazed, because these books had great influence on me, Michael Berry and Gordon Linoff. Sorry, there's a really good books. I really would recommend them to anybody.
Wonderful, Michael Berry. If you're truly not the author, you have a great name. So you have a common name.
Yes.
Great. That really took Dejan and me by surprise.
Okay.
And
Okay.
Dejan, you would be wondering, why is Michael Berry coming to this Geek Talk and asking questions?
Exactly. I was thinking like he probably knows things much better than I do. And
Great. Thanks, Michael, for all the lovely questions. So we don't have enough time, Dejan. So quickly, two more questions. So if you could quickly answer them. One is, when learning R and Python, do you have any advice on picking up a new language?
Yeah, I would say like this: if you really want to go purely in data science area, then probably R is better choice, because it has so many libraries. You will find the solution for any problem. You will probably even have to find a problem for an existing solution. But if you want to go more in general development, then Python is a full development language. So you can develop whatever you wish. With R, you probably won't go and develop, I don't know, websites and so on. But with Python, it's a fully fledged language, and on the top of it, you can also do some data science.
Great, Dejan. And Chris McCarthy, she wants to know the name of the book title there. So if you could just call it out, someone can type in, Satya can type in. What are the book titles, Dejan, that you were showing just now?
Yes, I will just type here to the chat. So
Yes.
it's Michael
Mastering
Berry,
Data Mining.
Gordon Linoff. These
And
are the authors.
this is good. You
And
can
the
just
book
copy
is
paste the chat window content into your sticky notes, so you get everything. Yeah.
Mastering Data Mining was one book that I showed, and the other was Data Mining Techniques. So these are really these two books. They are getting old now. You see that they are still using data mining expression. But as I said, I really love these books. So when I saw Michael Berry, I said, come on, this would be really a great honor. Not that, of course, I'm very happy that this Michael Berry was with us, but for a moment, I really thought that this was the author.
Great, lovely interaction, Dejan, with the audience today. We are just closing in and bang on time. So friends, thank you so much for joining today in this Geek Talk with Dejan Sarka on data science algorithms. Take a moment to visit dataplatformvirtualsummit.com. Join us for upcoming Geek Talks. We do a lot of free stuff. So be part of dataplatformgeeks.com And yeah, make a copy of the chat window so you will have all these book titles and all the links are available. And Dejan, thank you so much for joining us, taking out time out of your busy schedule. We hope you get back to those projects once more in full force if you're not bored with them anymore. Any closing thoughts for the audience, Dejan, before we wind up?
Well, I would just say thank you for coming, and I really hope that we will see each other again on the Data Platform Summit. Join my class and definitely join this great conference. And Amit, thank you very much for inviting me.
No, thank you. And I should thank Dejan once more because he allowed the class to be recorded and the recordings to be shared with the delegates. Not every speaker does that. And we are very grateful to our Data Platform Virtual Summit speakers. They have agreed for that. And, you know, the community is the real winner here. Thank you so much, Dejan. Thanks, people, for joining.
Thank
Hope
you.
this was worth your time. See you soon in another Geek Talk. Have a good day. Bye.
You too. Bye.
Thank you, Dejan. Bye.
Bye.
Thanks, team.